What's up, guys? Welcome back to another live stream from Scalar Learning. And today we are doing more ACT math. And we're continuing from where we left off. This is the Manhattan Prep book, the 5-pound book of ACT practice problems, and we're knocking out the math section. Okay, so we're starting today. Again, we're working through the pre-algebra section. Now, the cool thing about this book that I do find that the problems are pretty solid and similar to the actual ACT stuff, but I like how it's broken down to pre-algebra, algebra, all these different topics like that. So that I do recommend it. So we're going to start with 18. This is not timed, so we're gonna a little slower pace to serve the needs of some of my other viewers that have asked for this. So here we go. Got the calculator up. The entire ACT is calculator. In thermodynamics, the efficiency of a combustion engine is calculated by dividing the useful work by the heat absorbed. I'm immediately setting this up like this, and then converting to a percent. And then we turn this into a percentage, whatever, right? Using the percent proportion. If an engine performs at 453 useful work and absorbing 700, you see I'm immediately turning it into something like this. What is the efficiency of the engine? AKA plug it into the little formula that we created, cross multiply. 453 times 100 is 40, that one, and then we divide it by, so it'd be 45300 equals 715x, because we cross multiply. And then we divide both sides by 715. You see that? And we'll get our percentage. It's a little muddled, but you see what I'm saying. We cross multiply, then divide by 715. So take that, divide it by 715, and we get about 63%. And there we go. All right, 19. What is the value of 322 plus blah, blah, whatever, rounded to the nearest 10? So this is pretty straightforward. 322, use a calculator most likely, but I will just sort of do it. And make sure to round to the nearest 10 after you do the addition. 11, 15, carry the 1, 13, 14, 15, 11, 15, carry the 1, 4, 5, plus 9. So 955 to the nearest 10 is actually 960. We'd round up because this digit is 5. So when it's 5 or above, we obviously round up. I think most of you guys probably know that rule. Okay, next. The annual return of an investment account is found by dividing the interest in dollars that it garners over a year by the initial amount of money invested to the account, assuming no further investments, and then converting to a percent. Okay, so same thing. So I'm sort of setting it up like this. So if $13 of interest is generated over a year, generated over a year by an account which 434 was initially invested, what is the annual return of the account to the nearest percent? So you see what I'm saying? So we're basically just converting the interest out of the total, turning it into a percent, set it up, cross multiply. 1300 equals 434x, divide by 434. So 1300 divided by 434, oops. .9, so about 3%, I guess. 3%. 21. From among the 8 members of an Olympic skiing team, one must be chosen. Crack my knees. One must be chosen to act as an ambassador. We got 8 members. One must be chosen. The ambassador cannot be one of the 3 captains, but the other members are equally likely to be chosen. So there's basically 5 members that can be chosen. If Miguel is a non-captain on the team, what is his probability of being chosen? Well, 1 out of 5. Because there's 5 people to choose from. There's 8 members. There's 3 captains. We can only choose 1 of the 5. He's one of those 5. So it's literally, he has 1 chance out of 5. 1 person out of 5. What is the value of this rounded to the nearest 100? I mean, literally just plug it into a calculator. I'll just do it here for fun, but it's 462 plus, what is that, 370? No, I'm sorry, 370, yeah. So let's write it like this. Stack it, 2, 3, 1, 8, and to the nearest 100. So since this digit is less than 5, we round down to 800. And that's it. Yeah, I feel like that's good. Sort of double checking it in my head. gut check, as I call it. A phone company charges a fee of 50 cents plus 10 cents per minute. 50 cents plus 10 cents per minute. If a single call, so this is what comprises the cost of the thing. And then if this whole thing equals $1.60, what is the total duration of the phone call? AKA solve for the number of minutes. So look, you set these equations up and boom, the work is sort of done for you. You're in such a great position. So now let's isolate number of minutes. That's what we're solving for. And I get 0.1 minutes equals this minus this is 1.1. We don't need the 0. Then we divide by 0.1. Anytime you divide by 0.1, it's just like you're moving the decimal over 1. So the minutes are 11. All right, next. For which of the following values of x will this be true? We see something like this, let's immediately cross multiply. But before we do that, let's reduce the fraction. If possible, we can reduce it to 1/5. Now let's cross multiply. Boom, boom. 1x equals 5 times 25, which is 125. We don't care about the 1. X equals 125. Boom. Dunzos. Numero nexto. When Pleasantville Apartments opened, they had 25 apartment units built. If they built in a, hold on, they had 25 built. If they built an additional 5 units per week, so 5 every week, and there are now 135, so this whole thing equals 135. How many weeks have passed? AKA solve for W. You see the setup? It just flows as you get into the mindset and habit of automatically turning things into an equation when possible. Remember, an equation just means it's a relationship between everything. Solve for W, solve for W. 5W equals 110 divided by 5 divided by 5. W equals 22. Boom. Dunzos. Next, if x is greater than or equal to 52, x is less than that. For how many integer values of x is the tens digit larger than the ones digit? All right, let's write them out. I mean, you can probably figure this out faster, but let's just write it out. 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, and 65. We got to include 65 and 52 because the less than or equal to, right? And then for how many is the tens larger than the ones? Uno, dos, tres. Not this one, 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 not this. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's it. Didn't really take that long. Not a terrible strategy, but you could probably figure it out without writing it out and be like, oh, well, obviously 52 to 54. So 52, 53, 54, and then you'd say, and then all the 60s, right? So all 6 of those. I don't know. There are 14 freshmen, 14 sophomores, and 12 juniors on a camping trip. If one of the students is chosen at random, what is the probability that the person chosen will not be a sophomore? So what's the chance of getting, how many non-sophomores are there? Well, there's 14 freshmen and 12 juniors. So 14 plus 12, that's the non-freshmen. What's the probability that will not, I'm sorry, non-sophomores. What's the probability that we won't choose a sophomore? It's 14 out of plus 12 out of, well, how many total people are there? 14 plus 14 plus 12. 20, that's 40. So it's 26 out of 40. And then they want us to reduce it. So we divide top and bottom by 2 and we get 13 out of 20. Boom. Boom. 28. The set S includes all the integers from 401 to 413. For how many of the integers in set S is the hundreds digit less than or equal to the units digit? From 401 to 413, I believe that language means we include 401 to 413. I'm like 95% sure that's right, but we'll double check, of course, when I check the answers. And again, you can already kind of see, and less than or equal to. You can kind of already see it's like, probably deduce the ones, but I'm going to write it out anyways. Okay, so where the hundreds digit, is the hundreds digit less than or equal to the units digit? So not here, not here, not here. here, 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 and here, and that's it. So 6. Oh yeah, we didn't even need these. Doesn't matter. It doesn't matter if these are included or not, because hundreds digit is greater than the units digit for those. Yeah. The cost in dollars of a certain metal alloy is directly proportionate. Directly proportionate means like an equation like this. So so like y is directly proportionate to x, where k is some constant, and we say directly proportionate to weight in ounces. Okay, so a piece of metal alloy. So the cost is directly proportionate to its weight. So the piece of this metal weighing, let's say the cost is y, just I'm arbitrarily choosing it, it doesn't matter, equals k times the out weight, which is 42. And there's our thing. What is the cost in dollars of a piece of this metal alloy with a weight of 18 ounces? Actually, forget this. No, it's a much easier way to solve this. Excuse me. Probably should have used a proportion, not the equation for directly proportionate. So we got ounces on top. We got dollars on the bottom. We've got 42 costs 280, and we want to know 18 costs how much? Done. And we got a calculator, so I'm not even going to worry about reducing it. 18 times 280 equals 5,040 equals 42x divided by 42 divided by 42. 5,040 divided by 42 equals 120. X equals 120. Boom. Done. Excellent. Let's move on to 30. A coin is randomly chosen from a bag of 60 coins. If the probability is 0.015 that the coin is a nickel, how many coins in the bag are not nickels? Okay. So we say that X, which is the number of nickels, out of 60. Okay, so this is the probability of nickels, but we don't know the number. But this actually, because remember, when we take that fraction, we're like 5 out of 60 or whatever it is, and then we actually divide it as we would, right? This is a division problem. It equals this probability value. So we just set this equal to 0.15 and we're good to go. Now let's solve for X. How do we do that? Isolate by multiplying both sides by 60. Boom. X equals, and then I believe that's 9. Double check. I mean, I know it is, but oops. 0.15 times 60 is 9. All right. Yeah. 4 problemos leftos. The following date chart shows the expected attendance at an upcoming medical convention on infectious disease. Great. What is the average number of expected attendees per antibiotics section? Here is my antibiotics section. What is the average number of expected attendees? Well, we take these 3 values, add them, and divide by 3. That's how we do an average. So 34 plus 38 plus 33. Divided by 3, 35. Yeah. 35. Oops. 35. Boom. Done. Numero 32. The hotel where the convention is being held, continuation, right, of that same chart, to manage the number of chairs used at various times. If 1 chair is needed for each attendee, the overall need for chairs will vary according to which of the following as the morning progresses. The need will first in. Got it. Let's see. So at 9, okay, let's do it like this. 9, 10, 11. So at 9 a.m., they will need 65, right? Because there's this session and this session at 9. At 10 a.m., it's this one, and this one, which is 38, 39, and 30. So that's 68, 77, 107. Let's make that so we don't repeat those. We already done these ones. Let's do squares here. I don't know. Different notation. And then last, let's do a star. I don't know. And then so 11, they need 33 and 37, which is 70. Okay. So it should go up by 32 and then down by 37, I guess. Let's see. Go up by 30. Wait, did I do the math wrong? 42. My bad. up by 42 and then down by 37. Is this one? Nope. All right. I think we're good. Feel confident. 33. Joan is riding her bicycle along a track at 15 miles per hour. Anthony, who is ahead of Joan. Oh, Anthony is ahead of Joan. Let's do it like this. Joan, Anthony, 15 miles per hour. Ahead of Joan is riding his bike at 12 miles per hour. If it will take 5 hours for her to catch him at their current speeds, how many miles ahead of Joan on the track is Anthony? All right. So it's a 3 mile per hour. Look, there's a lot of ways actually I can do this. We can use the distance equals rate times time equation, and we could say that. But look, here's how I'm going to approach this. She's going 3 miles per hour faster than him, right? So that's the differential. That's really all we need to know is that, hey, she's going 3 miles every hour, and in 5 hours, but relative to him. So in 5 hours, 5 times 3, it's 15 miles. So they're actually 15 miles apart. But let me see if I can set this up a different way to make more sense. So it's like, okay, distance equals rate times time, right? So her rate is 15 times time x. Okay, we don't know how long they've been riding. It doesn't matter. No, wait, how can we... No, wait, we can set this up differently. Watch this. 15 times 5. Wait, so this is not... Oh, this is... But then we have to figure out... Sorry, this is actually not going to work because she's at x and he's at... We don't... No. I'm not really sure how to... I'm setting this up wrong with this distance equals rate times time thing. We could set up a table. I'm not going to do that. Sometimes teachers have you do like a distance rate times table. This is the best way, what I just did. But I know we could do this like a different way where we say Joan, Anthony, and it's like... We sort of set up an equation based on the values we put in the table, right? She's going at 15 miles an hour. He's going at 12. We're looking. Oh yeah, we're looking for where their distances are equal, and 15 miles per hour. We'll take Joan. Oh yeah, so we could say we don't know how long Joan has been riding. Yeah, see, you know what? This approach is kind of more confusing. Instead, I would do what I just did, is look at the differential and say, hey, she's riding 3 miles per hour faster. So if it's going to take her 5 hours to catch up to him, that's the pace at which she's gaining on him. So, 1 hour she'd gain 3 miles, 2 hours she'd gain 6, so on, and 5 hours she'd gain 15. So that's how far back she is, 15 miles. Okay, last question, 34. Sorry I spent so much time on that one. This one is, what is the value of x? Okay, let's get this into scientific notation. Now, we could do this a number of ways, actually. Could even use logarithms, to be honest. But I think what they really want us to learn, apply scientific notation here. So let's convert it to scientific notation where it looks similar. So I'm going to move this once, twice, 3 times. We want the decimal there. So that means it's 2.438 times 10. Now, when we move the decimal to the right, it's going to be a negative exponent. If we moved it to the left, it'd be a positive exponent. You want to think about this number here is getting bigger, therefore this one has to be in the negatives with the exponents. One way I remind students. It's actually 10 to the negative third. Now, once we do this instinctively, you may not even know how to solve the problem or wonder, do I use logarithms or something? But now we're in this awesome spot where they look equivalent, essentially. These are equivalent, and these are almost equivalent. Now we just know that the x obviously has to equal negative 3. Another way you could do this is we could have gone here. We actually could have isolated x as follows. We could have divided both sides by 2.438. 2.438. And then we'd get 10 to the x equals whatever 10 to the negative third is, like 1.001, right? I think. And then we could, I don't know. I guess this isn't, again, the optimal way. But if we could figure out that this is 10 to the negative third, that might be okay. You could also take a log of both sides, which is not like ideal. And then you move the x down there. So there's some different options. That's the standard way to solve a variable exponent is you use logarithms, because you can use a log to bring the x down. And then there we divide log of 0.001 by log of 10. That's the other option, but obviously this is scientific notation. That's the best way. Let me just quickly double check the answers. Okay, we've got GDHAJ. GDHA. Oh, what? J? 22? What the heck? I actually got that wrong. Hold on, let me see. Oh, no! I misread it. You see that? I read that as a 2, so I multiplied it, became 462. Wow, that was a really silly mistake. 3 times that is 693 plus 370 is 36. Carry the 1, 10. And then rounded up is 1100. So it's this guy. Oh, look at that. Really bad mistake. Got to read that carefully. AFDJ. Okay. AFDJ. Then we've got 27 is EGAJ. Are you kidding me? I got another one wrong? Oh no! What is the problem? Man, I misread this one too. Not nickels. So how many coins in the bag are not? There's 9 nickels, which means there's 51 out of the 60 that are not nickels. Darn it. Again, misread that or just kind of rushed. I don't know. 2 mistakes. That's pretty bad. But hopefully that's a learning lesson for you guys. If you're wondering, right, obviously, like if you've seen my channel a lot, you know I'm never doing these I'm doing these problems for the first time. I'm doing them live because it's obviously more accurate and it's more beneficial, I believe, for you guys to see me go through the actual problem solving process than to rehearse this and whatever. But these are just really bad mistakes. Okay, then this is C. Good. This is the first video you're watching. Usually I get them almost all right, but I do make mistakes sometimes. It's just part of the reality of the way that I've chosen to run my channel. Next is FEG. F, E, and G. All right, cool. So that's that. Those are the problems. Oh, you actually called it Aben. What is it? Ahyan. Yes. Yes. I should look at my comments. I'm sorry about that. Thanks for posting. Hey, you're very welcome. Yo, you're right. You're so right. Thank you for paying attention. And guys, I hope you liked that video. If you did like it, please click the like button. Really appreciate it. If you want to see more from the Scalar Learning channel, definitely subscribe. We're going to be having ACT math every Monday on the regular. And if you guys got any requests for additional problems or things you want to see, make sure to drop me a line. Let me know. Be happy to accommodate. And thank you guys so much for joining. And I'll see you all next time.